Alright, so daylight is fading quickly here as I try to explain this stuff. So it looks like we're going to be down to the wire trying to understand inheritance in C++. So I left off with a student class which extends a person class. And I want to show you something kind of peculiar that can happen when you do a deep copy, not a copy of a reference, but a copy of the entire object to its parent type. So I can say something like this. I can say student, or not student, I'll say person pChris is equal to Chris. So this is going to copy Chris over to an object of its parent type. Now just to show you that this actually did copy, let me go back and print out the pointer address. I forget how to do that in IOStream, so I'm just going to do that in C real quick. So I'll say printf-p, so I'll say, the address of Chris is this, address of Chris, and then the address of pChris equals this. So I just want to show you that these are actually different things, that it's actually made a new variable here and copied things over. Made a deep copy instead of just copying the reference. Okay. Whoops, it's a little hard to see, but so let me clear things up. Okay, so I see that these are two different addresses. I see that this one is later in memory. Okay, so that worked. So it seems to have copied things okay. So if I say pChris.printinfo, what's it going to do? Is it going to call? Is it going to know that it's going to use polymorphism and know that I should be calling printinfo in here? Or is it going to call the printinfo in the parent class? So I don't know. If this were Java and I copied things by reference, then it would be smart enough with polymorphism to know that it should be calling printinfo of the subclass here. But let's see what it does now. Okay, so it did not call the student version here. It actually called the parent version, so it only printed out the name and the age. So it actually used the person class as printinfo. Okay, let me see if I can get it to. Let me see if I can back up and get it to call the student classes version. So what I'll do is I'll make a pointer. I'll say. First I'll make it a person pointer. I'll call it p, I'll say that is equal to the address of pChris. But let me cast that as a student type. So this is a reference to the copy I made. So I will cast that as a student reference instead. Okay, so I'm just going to change what I think the type is of my reference, and I'm going to say, all right, so now let me call s printinfo. And let's see what that does. Oh, weird. Okay, so it says Chris is 31 years old, class year Chris. But that's not what I said. I said class year sophomore, right? So it's getting really confused. Because it's actually done something called object slicing here. So when I do a deep copy of a subclass to a type of its superclass, it simply chops off everything that wasn't part of the superclass. So I had this thing class here, but it's gone when I say pChris is equal to Chris. So you have to be very careful when you do these deep copies. Because if I then try to say, well, no, this is actually a student reference, and then I try to call this method, this is going to call the method on the student class. But you can actually run into segfaults this way, because those variables don't even exist anymore. Okay. So that's called object slicing. Whenever I do a deep copy of a subclass to its parent class, it just chops off everything new that I added to the subclass. So I have to be careful about that. All right, but what if I just try to do polymorphism a little bit more like it was in Java? So instead of doing deep copies, let me just copy references. So I'll put this in its own little thing. I'll call this void copy I'll call this deep copy slicing. Okay. Let me try another version of this, which is shallow copy polymorphism. So let me do something a little bit more like Java did. And I will say, all right, so I actually want to make something of type person, but I will actually make them a student. So remember, this is like in the COVID simulation. We had an array of people, but we may have initialized one of them to be a COVIDiot or an essential worker. So here I'll just say person is equal to new student with these parameters. Okay. So far so good. Of course I should, since this is a dynamic variable now, I should remember to delete it when I'm done. But I'll do some stuff in between. Okay. So let's see now what happens if I just say person print info. Is it going to be smart enough to know, to do the kind of polymorphism like I do in Java, and actually know that, hey, even though this is a reference of type person, is it going to realize that it should be calling the print info method on the student type instead? So let's just take a look and see what we get. Oh, of course I have to say delete person. Okay, there we go. So I just say what I'm deleting. All right, so let's run this. Ah, no. That's interesting. So it actually called the parent class's print info. So it seems like the reference actually, by default, is going to tell me which one it's going to call. If I instead say this, okay, student as person. If I just cast this as a student reference, then it'll work actually. So I'll do these back to back. So I have to remember, oh, this is actually a student. Let me make sure it's a student reference, and then I'll call that method. So now we'll see the first one prints Chris 31 years old, but the second one actually prints out the class year 2. But that kind of stinks because I had to remember that this was of type student. I thought the whole point of polymorphism was that at runtime it would determine which subclass it was. So that's a bit of a bummer. But there's something we can do about it. There is a version of runtime polymorphism in C++. You just need one extra specification. So I don't normally have to do this, but if I'm going to want to have polymorphism happen, for this to be smart enough in my print info method to know that it should be calling it in a subclass, well, in the parent class, I have to implement it with this designation. I have to say virtual void print info. So that keyword virtual makes all the difference. What it says is, at runtime, I want you to be able to determine which class this is going to run on. So look, all I did was say virtual void print info. And now, even though it's a reference of type person, you'll see that when I run it, it will actually call the correct subclass print info method. See that? So all I had to do was add the word virtual. And then polymorphism works as I anticipate.